Despite all our advances in rocket technology and spacecraft design, space itself hasn't gotten any friendlier. The same 5 killers that threatened Yuri Gagarin in 1961 are waiting for today's astronauts with the same lethal efficiency. Understanding these threats reveals why modern spacesuits represent some of the most complex engineering ever attempted by humans. First comes oxygen deprivation, the most immediate threat. Your body stores roughly 4 minutes of oxygen in your bloodstream and tissues. Without a pressurized oxygen supply, you'll lose consciousness in 15 seconds as the oxygen in your blood gets used up and carbon dioxide builds to toxic levels. Brain death follows within 4 to 6 minutes. There's no gradual decline, no dramatic gasping for air like in the movies. Your vision narrows, your thinking becomes fuzzy, and then you're gone. The pressure differential presents an equally deadly challenge. Earth's atmosphere presses against your body with 14.7 pounds per square inch. This pressure keeps your bodily fluids in their liquid state and maintains the proper function of your organs. In the vacuum of space, this pressure vanishes instantly. Bodily fluids begin to vaporize within 10 to 15 seconds. The moisture in your lungs will expand rapidly, and your blood won't boil immediately because your circulatory system maintains some internal pressure. But within 30 seconds, nitrogen dissolved in your bloodstream will form bubbles, causing decompression sickness and organ swelling that can kill you even if you're rescued. Temperature extremes create the third major threat. When sunlight hits you directly in space, temperatures reach 250 degrees Fahrenheit. Your skin would suffer severe burns within minutes, and your internal organs would begin cooking as your body's cooling systems fail completely. In Earth's shadow, temperatures plummet to negative 250 degrees Fahrenheit. Without the insulation of an atmosphere, your body heat radiates away rapidly, causing hypothermia that would kill you within hours even if you somehow survived the other threats. Cosmic radiation forms an invisible but constant danger. High-energy particles from dying stars and solar flares bombard anything in space with radiation levels hundreds of times higher than what we experience on Earth. A single large solar particle event can deliver a lethal dose of radiation in minutes. Even the constant background radiation will damage your DNA, increasing cancer risk and causing radiation sickness during extended exposure. Your body has no natural defense against these high-energy particles that pass through normal matter like it doesn't exist. Micrometeorite impacts represent the fifth threat. Tiny particles traveling at speeds up to 45,000 miles per hour. A fragment smaller than a grain of sand carries enough kinetic energy to punch through human tissue like a bullet. The International Space Station gets hit by objects this size regularly, requiring constant repairs to solar panels and exterior surfaces. A single impact to an unprotected human body would cause massive trauma and rapid death from blood loss and organ damage. The margin for error remains absolutely zero. A pinhole leak in a suit's pressure vessel will kill you in minutes. A failure in the oxygen supply system means death within the time it takes to recognize the problem. A malfunction in the cooling system during sunlight exposure will cause fatal hyperthermia before ground control can even respond to your distress call. A breach in radiation shielding during a solar particle event delivers doses that cause death within days or weeks. This zero tolerance for failure explains why modern spacesuit development has become so incredibly complex. Engineers must create systems that work perfectly in an environment that destroys everything. Every component must function reliably while exposed to temperature swings of 500 degrees, radiation that would kill unprotected electronics, and the constant threat of high-velocity impacts. The suits must maintain perfect pressure integrity while allowing enough flexibility for complex manual tasks. They must provide life support for 8 hours or more, while remaining light enough for astronauts to move effectively. Modern spacesuit engineering has achieved something that borders on the impossible, creating a portable life support system that can keep humans alive in an environment designed to kill them instantly. These suits must function as personal spacecraft, complete with life support, communication systems, radiation shielding, and impact protection. They represent the culmination of 60 years of learning from failures, near misses, and the constant refinement of systems where anything less than perfection means death.